Besides, as an engineer, we are aware of the safety in our daily life. Therefore, we need to have some considerations on design regarding to the safety issues. So one very basic thing is that, for example, you have a hook fixed on the wall, right? Then sometimes you may want to hang something on it. Then the engineer or the manufacturer of this hook will say, okay, the maximum load of my hook is 5 kg or 7 kg, something like that. So similarly, in our solid mechanics course, we consider the following safety considerations. First, it is a common sense that the applied stress, you apply a stress on a piece of material, then you should not apply a stress which is too larger than the allowable stress stipulated by the manufacturer, right? So it says 5 kg, so you should get rid of putting 7 kg of material on that hook. Besides, since in our course we talk about deformation frequently, so we will discuss the allowable deformation. So the deformation of a piece of material should be less than the allowable deformation. While allowable deformation is often come from the allowable stress, because as we know, allowable deformation is a function of allowable stress. Apart from that, as we have discussed in the previous tutorial, what is the stress that the material will undergo permanent deformation? If the applied stress is larger than a stress called the yield stress, we don't want a piece of material to be destroyed. Therefore, we try to get rid of the material to hold a load which is larger than the yield stress. Therefore, we define the safety factor to be the yield stress divided by the allowable stress. And notice that it should be always greater than 1. That means your allowable stress should never greater than the yield stress of the material. The allowable stress of a piece of material is just rewriting this safety factor formula, which is sigma allowable stress equals to the yield stress divided by the safety factor.